Good evening, good evening, good evening, ladies and gentlemen. Welcome to WeatherBrains episode number 938. This is the weekly show that's all about weather. Almost 18 years old. Our 18th anniversary is coming up here in a couple of weeks. But if you've never experienced this program, this is the pre-show. This is the magical part of the program where we often we do three things. We share very boring personal stories, humorous anecdotes, and we say outrageous things. And it's very odd. Everybody is already online here. Everybody, except for a few. Let's see. We've got Neil that might be out tonight. He had a meeting, I think. What was his meeting with INSEP?
INSEP, he said, yeah.
INSEP. Yeah. For those that don't know, Dr. Jacobs is the numerical weather prediction czar of the world. And so he has very important meetings he has to attend. And Kim has some health issues in her family. Troy is out. He'll be back with us next week. He's got some work he's having to do there. But also in the sick bay, we have James A. And this is not the regular show. We're not doing the intros yet. But I guess we can say this on the pre-show. You've been ill. Do you want to share anything about your illness?
I have managed to avoid COVID for nearly 4 years, and it finally got me, thankfully, after the busy holidays. So everybody was already back at work, and but all is good. I'm definitely recovering. Looking forward to heading back to work here in a couple of days.
Well, glad you are okay. You know, I got ill in early 2020. I think it was COVID that it never showed up in any of the tests. But again, I don't get sick that often. It's very rare. But I've not had COVID since then. I've had my bowel obstruction, which is my weirdness of the last 3 months. I have to turn in a quarterly list of all the schools I visit for the station FCC file. And there was this weird absence, for like this whole week. And I'm thinking, what is this? And oh yeah, that was the hospital stay. So anyway, but no, the gang's all here, and we've got some, again, just so you'll know, we've got some very active weather, and it really affects poor old Jen because she does the weather for a gazillion radio stations, and
yeah,
she's got everything from blizzards to tornadoes and floods and everything else. And we've got some pretty active weather down here where I am. And again, I've said this before, and just for those that don't know, I'm actually at work in my real job. It's television meteorologist, having to handle duties there. And sometimes when it's hectic, kind of takes me a little away from this. But we've got the triple threat of gradient wind, flooding, and tornadoes in my state tonight. Thankfully, the tornado threat's far to the south of where I am. It's near the Gulf Coast, Mobile, Pensacola, Panama City, the Mississippi Gulf Coast. It's going to be a rough ride tonight, and looks like a lot of folks are not going to sleep a lot. Jen, have you slept any in the last 2 weeks?
I've slept a little bit. Today's been a long day. Tomorrow is going to be busy. I've got to get up early and do some stuff for Kansas City. Hard part today was this: when was it going to switch to snow in like Topeka, right along that I-70 corridor? It was so hard. And completely real time. You just could not even you didn't know. It was hour to hour here to try to figure it out. So I'll do some stuff in the morning, and then just do the rest of the 70 cities I got to cover.
There you go.
From coast to coast.
It just dawned on me that we have the national NCAA football championship game
That's
tonight, right?
Yeah.
Michigan's up 7-0.
Oh,
Really?
I totally forgot that was on television. Was it on ESPN?
It is. Mm-hmm. All the ESPN channels are running their mega cast.
It looks like you're at the restroom deal in a venue because there's a W and an M.
Yeah. It does kind of look that way.
They were in a tornado watch when leading up to the game, and had
Oh, that's right, because they're in Houston.
tweets about the stadium was leaking for the first time ever, and yeah, the weather all moved out, it seems like, but yeah, they were little iffy there to start before the game.
At least no TV meteorologist is going to be torched for interrupting the game because it's not on broadcast television. It's on ESPN, which is good. And speaking of television, welcome. It's the Monday Night Weather Party. I know that the weather is very active in the TV markets where we're on. And trust me, I am watching the radar like a hawk. And if you are in the Birmingham market, there's no risk of severe storms tonight. The air is cold and stable. You might hear some thunder, but the gradient winds are going to be screaming. We might get a gust to 50 miles per hour in spots, and we've already got power outages now. And so that's going to be pretty much the situation all night. So we'll do an update on the weather as we go here. But let's get started. Let's roll the recorders. Here is track number 1 and track number 2. And I got the new the new weather band ad here, so we're good to go. So here we go in 5, 4, 3, 2, 1.
Join the American Meteorological Society by becoming a member of the band. The AMS Weather Band is a global community of weather enthusiasts dedicated to learning and sharing their love of science. Visit amsweatherband.org to learn more and join the band today.
You're listening to WeatherBrains. They're kind of a big deal.
You heard what that man says. We're kind of a big deal. That was Bill Curtis. Come on now. Hey, welcome to WeatherBrains. This is episode number 938. We're back on Monday nights. This is for Monday, the 8th of January, 2024. And we should be on Monday nights for a while. We're glad you're here. It is a very active weather night across the fruited plain. We've got some active weather, goodness gracious, in fact, in so many places. And we'll talk about the ongoing weather as we go here. But anyway, welcome on a Monday night regular time slot here. Good to be back. Let's just go right up to our Arctic correspondent, Jen Naramore, who is in Ohio. And so what's on your table up there? You got flooding, blizzards, wind? What's going on?
It's mainly rain and wind here for now until we get the cold blast for the weekend. And then we do get the coldest air we've seen in quite a while in here with low teens, maybe right around 9-10 degrees coming Saturday night, Sunday. So we'll definitely get some snow if we get some disturbances in then. But for this big system coming in now, it's just a quick shot at snow, then rain and the gradient winds. I mean, this is a cranked up system that's really causing big problems with just general wind for a lot of the country. So, and I've pretty much covered all of it. I got in there this morning. I'm like, oh man, every city has something, some kind of advisory or watch or something. It's craziness.
It is. And I think, Rick, don't you have a blizzard warning for some counties in your CWA?
We've got a blizzard warning, I think, for 4 or 5 counties in far northwest Oklahoma. First one that we've had since 2015 in our area. So kind of a rare deal. The wind has been kicking up. We don't cover the Panhandle, but the Panhandle has been taking the brunt of the blizzard so far today, and up into western Kansas too. But most major roads, highways in the Panhandle have been shut down for hours. So it's the real deal.
Yeah, and goodness, James A., you just dropped the OZ sounding from Slidell. That looks nasty, man. Goodness.
Yeah, this wind field's unbelievable, and we've been lucky that it's been as quiet as it has been along the Gulf Coast. A couple of tornado warnings, but not many.
Yeah. So how you doing? You've been a little under the weather.
Yeah, I've turned the corner, doing better. Hope to be back at work next couple of days and terrorizing my coworkers at that point. I think they enjoy the break, to be honest.
Excellent. And we should mention that we've got Dr. Neal is out. He had a meeting he had to attend this evening with some folks, I think, from INSEP. Troy has got some academic work he's having to deal with, and Kim is dealing with some illness in her family. But you know what, Bill Murray, we're here, and let's bring in our guest. It's going to be a good show tonight. Can't wait.
Yeah, James, I'm really excited about tonight's show because tonight's guest weather brain is a researcher and trainer at the European Severe Storms Laboratory, ESSL, where they conduct research on severe convective storms across Europe, climatology, forecasting, remote sensing. They gather reports of severe weather in the European Severe Weather Database. They organize conferences on severe storms. One of our great weather brains, we just learned, has attended all of them for many years. Harold Brooks will be joining us in March. And they facilitate the training of meteorologists on convective storm forecasting through courses and seminars and test beds, all the kind of things that we love. He also chases storms from time to time. Tomas Pucic, and I think I got pretty close to your recording that you sent me. Welcome to WeatherBrains.
Thank you very much. Hello. And you totally hit it. My surname, very good. And it's not easy to pronounce it.
It is very fun to say, though. That is for sure. So we're very honored that you'd stay up late with us. What time is it where you are, Tomas?
It's 2 a.m. currently, but it's okay. I'm very excited to be here.
Well, we are even more excited. So talk to us for a couple of minutes about your journey into meteorology and how you got into the current role that you have and what that involves.
Well, I have been interested in weather ever since I was a little kid, and especially in severe convective storms and the thunderstorms. So that was my destiny, and I was always interested in becoming a meteorologist ever since I was a little kid. So when I went into university, I did my bachelor and master thesis. Both had topics of dealing with forecasting of severe convective storms. And then I did my PhD with the European Severe Storms Laboratory. So I ended up here.
We should be referring to you as Dr. Puchik. So we'll do a better job going forward.
Thomas
That's
Thomas
very
okay.
impressive, Tomas. Talk about the work of the ESSL. I know our folks are really interested in hearing about it.
Well, ESSL was inspired by NSSL. I guess that's the organization that you know. And the ESSL is actually a pretty young organization. It was founded in 2006, and it was founded by several individuals, more or less as a voluntary activity that they had besides their job, with some of the aims of collecting the data about severe convective storms across Europe. That was also the year when we started European Severe Weather Database, which is a database like you see when you look at the SPC website and you have the storm data with the reports on tornadoes, hail, and wind gas. And I have to say that ESSL to this date, we are growing slowly but steadily. But for example, we are, at least compared to NSSL, a pretty small organization. And we have currently 7 full-time employee job equivalents. So we are compared, I think NSSL is quite a bit bigger. But we try to do some of the things that you have already described. I think one of the most important ones is providing this database of severe weather across Europe. And this is something that's not so easy as in the United States, because we have to work with many different countries, with many different languages, and different countries have very different approaches to, for example, spotter programs. So we actually do employ. We have 2 employees that basically just deal with the European Severe Weather Database, and they actively collect the data about severe weather all over Europe, especially from the countries where we do not have a cooperation with some spotter organization or with a National Meteorological Institute that would submit the severe weather reports for us. We also organized the conferences on severe storms. So this was something that was started in 2000. I think the first one was in Toulouse in France. I'm not 100% sure about that. But what I do know is that, as we already said, Harold Brooks was in every single one of them. And he is either the only one or one of the 2 people that did that. So that includes the European community. So I think Harold is very proud of this title. You can ask him about that when he joins your show in March. So these are the conferences on severe storms. We also do research projects on severe convective storm forecasting. We provide testbed. So also the NSSL, SPC, they do the annual hazardous severe weather testbed, and we do similar thing where we provide a facility for exchange between the forecasters and the developers of some new products that concern severe convective storms, and try out the new products in the quasi-operational setting, and then let the developers know how their products performed. So this is another thing that we do.
So, Tomas, what is the source of your funding for the organization? Are you a quasi-governmental agency or funded solely by grants? How does it work?
Okay, well, the simplest answer to that is complicated. we have income from multiple different sources, so we are trying to operate on a European level, but we do not have a funding from European Union. A lot of people think that we are funded by European Union, but we are not. Currently, we are funded from a research project that we have within Germany and within Austria. So ESSL has 2 seats. One is in Germany and one is in Austria. We have research projects there. So that's one part of the funding. We also have currently some research projects with some European organizations, such as the EUMETSAT, that's the European Satellite Organization, and then the European Center for Medium Range Weather Forecasting. So that's the model that is competing with the GFS all the time. You may have heard about that. So we have some cooperation with them. We do have members, institutional members, so they can be the weather institutes, or sometimes some insurance or reinsurance companies that are very interested in looking at the severe weather data set. So that's another source of income that we get.
James, I know you want to ask some questions and got a comment to make too, so why don't you go ahead?
Yeah, and when you say that funding sounds complicated, that is not unlike NSSL here either. And they're taking money from all these different agencies.
Mm-hmm.
Wanted to ask you a little bit about severe weather climatology and frequency and hotspots and how that compares to the United States, where most of our viewers and listeners are going to be familiar. I know we've seen some spectacular video of tornadoes in Italy over the last couple of years.
Yeah, so let's start with tornadoes. I guess that's the most exciting topic, right? So definitely when we compare it to the US, Europe has fewer tornadoes compared to the US. So in the ESWD, we collect both tornadoes over land and tornadoes over water. So also the water spouts. So together with the water spouts, we have now on average around 800 tornadoes per year. Now, if we would just select the tornadoes that are only over the land, then this is typically in these last couple of years 250 to 400 reports of tornadoes, which is not too shabby, right? It's still more than majority of people would think. Concerning the significant tornadoes, so F2 or stronger, we typically have around, now on the average, it's 37 per year of strong tornadoes. Violent tornadoes are very rare. So we have one F4 or F5 tornado, let's say, every 5 years on average. So there, the frequency is definitely less compared to the US. And concerning the hotspot for tornadoes, I mean, in general, if you would also take hailstorms and the tornadoes, then the north and northeastern part of Italy, that's the hotspot. Northeastern Italy typically has one strong tornado per year. So that's really the region that gets hit very frequently. And then another region that also has quite a few reports of tornadoes or even strong tornadoes is between northwestern France, then eastern Benelux, so Belgium, Netherlands, and western and northwestern Germany. So that's another region. That's the hotspot for tornado. And for hail, it's quite strongly related to orography. So if you open a map of Europe, you will see that our orography is pretty complicated, especially in some parts. And that, I think, is also the main difference between how the US and European severe weather events evolve. You have a very long mountain chain, and then a lot of plains and lowlands. And in some parts of Europe, it's a lot of mountain chains with different orientations, and that often leads to a very small area, sweet spots, where the severe weather really occurs. So, for example, we have Alpine Range, which is west to east oriented, and there you have the hotspots of hailstorm occurrence just on the foothills of the Alps. So that's maybe one of the interesting things when we compare Europe and the US. And also because I like to watch the weather evolve over the US, especially when the SPC issues some higher risk. I will stay up quite late, even to 2, 3, 4 a.m. and watch the situation unfold. It's quite teaching for me as well. And I would say that over US, you have large warm sectors with very high K values and very strongly curved hodographs. And it is often the forecasting question, okay, is initiation going to happen or not? And I have a feeling in Europe, we do not have as many of these situations where you have very favorable conditions over a large area, but rather these favorable conditions are very frequently associated with the mountain-induced circulations, and they are confined to much narrower areas. So we typically do not have such a big issue with initiation, especially in some areas because there are a lot of mountains. But it is more problematic to get a good overlap of high cave and, let's say, very favorable vertical wind shear. And this favorable overlap can be very small in terms of the aerial size.
Really fascinated by the role that orography plays, and I understand that you have a field project going on to study that. Is that right?
Well, we are planning it. But it already has a acronym theme: thunderstorm intensification from mountains to plains. And we are currently in the planning phase. So we are looking for partner organizations from National Meteorological Institutes and from the universities. And there are a lot of people, a lot of organizations are very interested. And this year will be a crucial find the funding part. So please keep your fingers crossed for us, because I think that this is a very big topic for Europe, how to correctly anticipate where these hotspots of severe weather occurrence form, depending on the different flow patterns, and to validate whether the high resolution convection allowing models are able to reproduce these areas and so on.
Really interesting. Yeah, when you mentioned acronym, I was glad to hear that, because you can't. That's the first stage of a field project, is coming up with an acronym, right? So you're well on your way. I wanted to ask you, really curious if you had any experiences, most memorable or maybe surprising weather events that you've studied. Could be tornadoes, could be whatever. Have you got one or two that really stick out that you'd like to kind of share with us?
Well, I can I can share numerous. But okay, if you ask me, like what was my biggest like personal experience with the severe weather event that was also quite surprising. This was 2 years ago in June 24th, and there was a violent tornado relatively near, like half an hour drive from the place where I currently am. And this was during the COVID time, and we were just having a test bed, and yes, we were discussing the situation, and there was high cape and a very strong shear. Well, at least in the deeper layer, in the low levels, the shear was quite questionable. In some models, it was pretty strong, and in some models, it was completely rubbish. So it was very clear that there would be supercells with some potential upscale growth later on, but big hail, that was, of course, this will happen. And tornadoes were questionable, and I did go chasing, and we tried to chase one of the supercells on that day. And I made some incorrect decisions. Of course, I guess we've all been there. And I ended up on the wrong part of the storm, and I would have to core punch to get to the correct side of it. But then significant hail started to fall, so the storm also produced giant hail along its path. So that was a no-go when the hail became too loud as it impacted the car. And we stopped at the gas station. And at that point, I didn't know what exactly happened with that storm. But there were other supercells coming, so we are still taking photos of them. And another supercell passed right over us, again with large hail. But then what was very weird is that the highway got completely blocked with the cars, but I was taken away by the storm, so I wasn't really watching the situation unfold. I mean, like what was happening elsewhere. And later on, I found it on Facebook. I posted a photo of the hailstone that I had found lying in the grass, and I saw a response, and there was a tornado as well. And I was like, "What? Come on!" I started digging up more information, and it turns out that just 3 miles south of where we were with the car, a tornado crossed the highway, and it was a major one. We did the next 3 days, we did a damage survey of the tornado, and even in those 3 days, we were not completely able to cover the whole path, so it was rated F4, and it was 27 kilometers long. Ooh. Yeah, so that was quite an event for me. That I was forecasting the event, and the tornado threat wasn't that apparent. There was a merger of two supercells before that could have played a role. And this was interesting experience for me because I didn't really think about the tornado threat too much when I was driving into the storm. I was very well aware of the big hail threat, but not about the tornado risk. And then, of course, spending the days after surveying the tornado damage. And the tornado killed 6 people and injured more than 500. So that was a very impactful event. And of course, the local communities and are not really prepared for such an event. So that was quite something. So some forecasting build up before the event, the unsuccessful chase. Well, let's call it as it was in terms of seeing that tornado, and then also surveying the damage. And actually now we have a paper submitted about the damage survey and the societal impacts of the tornadoes. That's really an event that I keep living with for multiple years now.
Wow. That leads me to my question, and it's actually not my question. It's a question from one of our listeners who sent us this email and was really curious about the International Fujita scale. And so since you mentioned F4 and doing a survey, can you give us kind of the lowdown of what is the survey, damage survey like for you, and how did the Fujita scale for you come about? How similar is it to ours? And were you a part of creating that scale? So kind of give us the lowdown on that.
Yeah, so we have been working for multiple years on the International Fujita scale. Actually, now we have released like a 1.0 version just a couple of months ago, and also our findings from this site survey of this violent tornado from 2021. It also served as an example of how the scale can be applied. We smoothed out the scale in some ways. So why did we develop this International Fujita scale? I think that one of the main reasons for that was that the EF scale, as it has been developed in the US, is very, very specific concerning how the houses are constructed in the US. So it's not very well applicable in Europe, where the building codes and building standards are very different. So, for example, if I had to describe you an average house that was in the path of this tornado that I surveyed, these are typically houses that have quite strong and heavy brick walls with enough connection between the bricks, and the walls are typically 25 to 40 centimeters thick. So that would be your typical construction of the wall, which isn't so typical in the US. I would say. Also, there are some differences, for example, in how the roofs are constructed. So because of that, and also because even within Europe, there are different practices from one country to another. So there are countries where more wooden buildings are prevalent, and then there are countries where the walls are even thicker and heavier. For example, if you go to the southern parts of Europe, so the International Fujita scale has a more, let's say, generic approach to the damage indicator. So, for example, when you have a certain type for building, for example, you do not have like what is a specific type of a building, but you assign a sturdiness of the building based on what material is used in the wall, and, for example, what is the thickness of the wall or the strength of the connection of the wall. And then from the sturdiness of the damage indicator, you go to the how much damage was done to it. And then from there, you get your rating. Also, one difference between the Fujita, between the International Fujita scale and Enhanced Fujita scale as it's being used in the US, and by the way, correct me if I say something not correct about the EF scale, is if I remember correctly, the EF scale works with the 3-second average wind, right? I hope, yeah. I see thumbs up. Thank you for confirmation. So instead, in the International Fujita scale, we use actually instantaneous wind speed. So our wind speeds stayed pretty close to what was originally proposed by Fujita, and we didn't tone down the velocities because we stay with this more instantaneous wind speed approach, but also because we have seen that the Doppler radar measurements that were taken very close to the tornadoes, they show that there are actually wind speeds observed that confirm what Fujita has originally proposed. So
It sounds like the scale is the EF scale is moving more toward it's almost it's going to be a resistance scale, the building resistance. And you mentioned how you're really looking at the building construction, and I think we're going to be doing a lot more of that, even more than we do now with the new whatever the new version of the enhanced Fujita scale comes up with. Just a couple of quick follow-up questions. I may have missed this. I'll admit I'm multitasking with the office and things here. We've got blizzard warning and fun stuff going on. So how's the scale set up? Is it 0 to 5 like the EF scale?
Yes, it is. It is 0. It is 0 to 5, but we actually have also a half degree increments now between 0 and 3. So you have 0, 0.5, 1, 1.52, 2.53. And the reason to do these half degree increments was that we have actually in these lower ranges of wind speeds, we feel we have really enough observations there to match the wind speed with the observed damage. So there are more degrees that you can assign in between of these 0 to 5. So you can go 1.5, for example, now.
That's interesting. Yeah, that's definitely different than what we're using over here. And you talked about surveys. Who does your surveys in the U.S. with the National Weather Service? It's almost always the National Weather Service office in that area sends meteorologists out to do the surveys. Who does the damage surveys for in your area?
Well, it depends. Sometimes it's the National Meteorological Institute that send their meteorologists to do the survey. So, for example, in the Czech Republic, it's done like this. But in many countries in Europe, it's not like that. So, for example, in Germany or in France, it is I would say weather enthusiasts or that go there. I mean, or the groups of meteorologists that like to do that. That by the way can also involve professional meteorologists, but they are outside of the governmental organizations and they go and they do these surveys. So, for example, in the UK, it's the Toro organization that does the field surveys of tornadoes. It's typically not the Met Office. And in many countries of Europe, it's like that it is, let's say, some enthusiastic weather organization or storm spotter organizations that go out and do surveys. And in some parts of Europe and in some countries, the National Meteorological Institutes themselves do the tornado surveys. But there has been some statistic about it, and I don't remember the exact number, of course, now, just when I need it. But less than 50% of national meteorological institutes in Europe actively pursue tornado damage surveys.
So Tom, let's talk about chasing for a moment. You've said you've given us a fascinating story about one of your events, but what are the best places to chase? Is law enforcement supportive of chasers? Do you have chaser convergence yet, like we do, or is that still a far off problem for down the road?
Okay, well, storm chasing in Europe. First of all, I will say very openly, I'm a terrible chaser. I still haven't learned from my mistakes, and I tend to drive too close to the storm instead of going well ahead of the storm and waiting for the storm to come. And I don't know when I will learn. So yeah, I'm not setting a good example for a European chaser community here. I have to be honest about that. I would say that, for example, chasing in Czech Republic is tedious. We do not have such. There are very few places where you have very open horizons. There are often very heavily forested areas. I mean, in the southeastern part of the U.S., right, the chasers face the the same problem that you have a lot of forested areas and it is tough to see the storm. But also, compared to the plains of the US, the road network isn't so regular. And yeah, well, for example, on precisely that chase that I have mentioned, I have wasted a lot of time waiting on the road constructions on the middle of the villages, and the road often goes winding across the whole village, and yeah, so the road network isn't the best, and sometimes it takes really a lot of time to drive towards the storm. So I would say it's maybe it's not yeah, it's not so easy here to have a good view of the storm, or to make a very good plan on how to chase the storm, or how to approach it. I mean, of course, there are many different parts of the US that have exactly the same problem. I'm of course imagining some kind of a Kansas situation, but or Oklahoma with a grid-like rows and wide horizons. But that's the problem. Law enforcement, I think that law enforcement, they do not at all realize that you are storm chasing is not really a big thing in Europe. I mean, there are some groups of chasers that even drive very large distances. I have a feeling that a lot of European chasers, they will tend to stay within their respective countries, so they will not go too much away. So let's say they will drive 100, maybe 200 miles, right? Sometimes you have to go to the storm for 500 miles, and there are not that many chasers that do that in Europe. There are some groups. So, for example, I know about a group of chasers that went to chase for a couple of days in northern Italy this year, and it really paid off. I mean, there were record-breaking hailstorms and beautiful supercells there, so that was that was all good. And chaser convergence, I don't know. I mean, you do get into traffic jams even without them, but I don't think I have ever seen. I have been in a chaser convergence of 15 people once, but that was like we set up a meeting point. Okay, let's go there, and that was the biggest one I have seen so far. So not like you see like a row of dozens of cars lined up and parked on the side waiting for the supercell to pass nearby.
Yeah. So I guess 15 chasers on one storm. That's just Tuesday in Oklahoma. Is all that is. So you pull up at the border station, you flash your passport and say we're here to chase tornadoes. Did they stop you and detain you for a few hours just to question you, Thomas?
No. Well, now within the European within majority of European Union, you can go across the border without showing your passport. It's called a Schengen space, so you can just cross the border. I mean, sometimes when when the countries get a little bit angry at each other for not doing something correctly. I do not want to get very much into politics here, because this is a weather show, but they can do like a temporary checkups at the borders, but otherwise you just go through the border. It's I guess it's like a state border in the US. Like, yeah, there is like a sign or something, but you go through.
Yeah, I know Dr. Kim Cloko McLean admired your response to a troll last week, and I think she was going to use it as her pick of the week, because you had some choice words for someone who was questioning your map that you had on the website, and some geopolitical boundaries that they disagreed with. And we asked James if we had permission to use that same language with our trolls, but we were denied. So sorry. So that's really fascinating. What are the best countries if you were going to get to come chase? Not that we would come and try that, but if you're in Europe and and you're good at this, what are the hot spots? For us, the plains are obviously a mecca. And, as you've alluded to, there's some places that are more difficult, but what are the best places to chase in Europe?
Now, are you now asking about the storms or the terrain?
Where you can see, and, you have good storms that,
Italy,
cooperate. Italy. That's
northern
surprising
Italy.
to me. That doesn't
Well,
seem like Italy would be a great tornado country, but I guess we see a lot of storms that produce some very photogenic storms there in
well,
Italy occasionally.
northern Italy has northeastern Italy has the highest recurrence of strong tornadoes from all the European regions, and it even sticks out more when you talk about big hail. So, for example, I can say just briefly that this year we had the European hail size record broken twice in 5 days, and basically in the same region. So on 19 July there was a 16 centimeter hail that fell in the northeastern Italy, 6.3 inch if you're making some fast conversions now. I have this written on the paper, by the way, this inch value, because I wouldn't be so fast with my
That's
brain.
impressive, though, Rick Smith. That sort of hail.
And then 5 days later, we were just making a post at the SSL about the record size hail, and then the same day a 19 centimeter one, so that is 7.5 inches, fell in the not so far from where that 6.3 inch hail fell. And so in this late July period, they had a hailstorm after hailstorm every day, a long-lived supercell. There was also one that produced an F3 tornado as well. So yeah, definitely that would be the country. So you can chase the storms there if the severe weather setup is correct, but also you can visit the mountains. They have very nearby this Chase region is there are, I guess, one of the most beautiful mountains in Europe, Dolomites, and of course Italian cuisine. And you can go to the sea as well. There is Venice nearby, which is supposed to be very romantic city. I have never been so far, but it's a whole package, if you ask
Yeah,
me. So
that just added to my allure of Italy right there. For sure, I have to put that on some of the tours that come over. Plenty of high-speed trains and other fun things too to go along with it. So, you mentioned these recent hail records. Have you seen a tendency toward larger hail? Are there climatic changes afoot there, Tomas, and any other changes you've noticed in weather patterns that might be changing as we enter a period of a warmer atmosphere around the globe?
yes. Actually, these last 3 years in Europe, we are smashing like one hail record after another in terms of the severe weather reports that are collected. And this 2023 was again record breaking. So 2021 was, now 2022 was even more, and now 2023 is even more. So, for example, for the last year, and by the way, the data is still not complete, so there will be more reports incoming, I know, from our database managers, but we now have more than 9,000 reports of 2+ centimeter hail. So that is bigger than 0.85 inch, something like this. And we had 1,700 reports of significant severe hail. So more than 2 inches, which is already quite a lot. So actually, in terms of the hail, numbers of large hail reports, now Europe is on very similar levels to the US, and we even surpassed the US, I think, last year in terms of the significant severe reports of large hail. Of course, the database is not homogeneous enough to say anything about the severe weather trends, even though these last 3 years are really sticking out quite a bit. But we did have a look at the conditions that are favorable. So we trained a statistical model output the probability of large or very large hail based on the predictors that we found that are conducive to very big hail. And then we apply the statistical model to the reanalysis data set from 1950, basically till now. And we have found that especially this northern Italy region, which also like goes towards Croatia and southeastern Austria, let's say, that this region is really experiencing a large, very significant increase in a number of conditions that are favorable for big hail. And in terms of the annual probability of having a hail over 2 inches over northern Italy, this actually tripled since 1950s based on this reanalysis data set. And we developed also this statistical model over the US. And interestingly, we have seen that over the US, the trends are not as significant. So there are some regions with increases, but they do not seem to be as strong as over Italy. And now our colleague is working with the global hail model and applying it on a global scale. And well, we will make the publication first, and these are very preliminary results, but it looks like it really depends from one region to another what the trends in the severe convective storms, or well, now more specifically speaking about large hail, are. So that's interesting that we are seeing quite a steep increase in the amount of very big hail in Europe in the last decade, let's say, but not in terms of tornadoes. So for example, in terms of tornadoes, we are also developing model for them, and we'll be looking at their trends from the perspective of the conditions. But for example, if we just look at the reports from the European Severe Weather Database, there basically, since the database has started, there is no significant change in the annual number of tornadoes in Europe. So perhaps for these trends are different from one to another severe weather type.
Thomas, I'd always heard that the French Revolution was in some ways related to a hailstorm or several hailstorms that year that produced a famine and led to political unrest. I don't know if that's really true or not. If you hear that sort of thing, I'd have to go back and check my facts, but that rings a bell with me.
Yes. I think it was in 1788. Once again, I think the French Revolution was in 1789, right? That would be 1 year before it. Yes, indeed, there was a very cold spring, and then there was probably two supercells tracking parallel to each other, and they produce a very, very long swath of hail, like several 100 kilometers long, and that also affected the outskirts of Paris. So, for example, maybe you have heard there is like this castle near Paris. It's called Versailles. Have you been there?
No, I know my wife has been there.
It's quite beautiful. If you can withstand the 2-hour long queue to get there, but yeah, that's better go and chase the storm in France, right? But yeah, there was the castle was destroyed by I mean, not the walls, but they had a lot of these nice stained glasses and everything, and that was very heavily damaged. And yeah, that partly led to a French Revolution among the other things. And well, actually, last year France got very badly affected by hailstorms as well. So they had drought. They had very major drought, and when something fell, it was in the shape of hail. So not like some nice beneficial rainfall, but they had drought and hailstorms. So also the crops and vineyards suffered quite a lot, and they had in terms of damage, overall it was more than $4 billion And then I think the figure can still increase for just in this one country for one hail season last year. So that was also quite something.
I just wanted to mention that I do the weather in Versailles in Missouri, though, and not in just so you know.
Tomas, how is Europe set for warning dissemination real time, and how does that get to the population with I guess the word I'm looking for is full democratization from those who are plugged in to those who may not have a TV, something like that. How do warnings get to people? Do they get to people? Are they issued? Do people know what they are? How does that work?
I think that again depends from one country to another. Also, for example, if you would ask me how the countries approach warning for thunderstorms, they have quite different approaches. So some weather institutes will do a lot of these nowcasting based warnings like you have in the US. So you have actually a storm based warning in the end. But some institutes will do like these longer term warnings. So for example, the weather warning primarily ends with what you would call a outlook or a watch. So there is a potential over this area, and they don't pursue the nowcasting part of the equation anymore. Sometimes it's also for the lack of personnel. So there are still even I know that in some institutes there is not the night shift. So yeah, then you cannot do a nowcasting. Concerning the warning dissemination, well, there are. I will base my answer on what I know from the countries I am more familiar with. So please bear in mind this is not applicable to all the countries European-wide, but warnings can be distributed through the emergency services. So in a lot of cases, the weather service sends a warning to the emergency services, and they then disseminate the warnings, for example, to the mayors of the towns and so on. Or for example, the fire brigades prepare that they need to have more people on the shift. To the public, we typically it's through media, especially some journals or so on, or you have the online media, you have, of course, now social media, Twitter, Facebook, or maybe some institutes do Instagram as well. I'm not sure about TikTok or or the other. And more and more weather institutes, they pursue the specialized apps, or sometimes you have like a push SMS notification that you can get on your cell phone. But once again, this depends on the country. I think one of the things that I really liked about the US, so for example, I remember the 27 April 2011 mega outbreak, which I was also, I remember I had the radar on, and then I switched on some local TV, and then I have seen these weathermen showing the radar imagery and then the imagery of this tornado. I think that one was bearing down on Tuscaloosa then, and I was like, wow. That was a crazy sight, and this is something that happens only very rarely in Europe, that they would interrupt a normal, like a regular program, and say some more specific information about the weather to get it, like, let's say, very rapidly to the viewer. So this happens only very rarely. Maybe with some major floods this can happen, but you do not want to bother people with this. Or I don't know, it would make sense to me, especially for especially in the televisions that are sponsored by the government. Let's say, so they are like they are owned by the government, that they would do this, especially in very severe situations or in rapidly evolving situations. But it's not like that. And you typically have like one or two weather shows per day.
James, anything else you want to ask in that regard? Because
No, that's fascinating because as technology evolves, it gets not, I want to say, easier to do continuous coverage of severe weather, but in many ways it is easier because you can easily find the data to put behind you and track these storms. It just seems like there's a big market for that.
Well, that's another interesting thing about Europe, if I may, and that's that the data is often not free. So it again depends from one country to another, but there are countries where the Weather Institute has to earn money. So part of the money is given by the government, but part of the money has to be earned. So they need to sell the radar products. They need to sell the information. So, for example, within Slovakia or within Czech Republic, the governmentally owned organization that, for example, deals with highways, they have to buy the specialized forecasts from the National Meteorological Institute that is also owned by the government. Yes, yeah, I will say outright, I think it's ridiculous, but it is how a lot of weather institutes operate in Europe. So you don't have access to all the data. Now there are more and more countries are moving, fortunately, finally, to the more open data policy. I think recently, for example, German Weather Service started sharing all their data. So you can have a look at all their radar data. You can have a look at, download all their model data and so on. And I think that that's, of course, direction that you can move in. So I worked on television for some months. I was doing some weather shows and this evening weather show, and I know that the national Slovak television, they had to buy data from the Slovak Hydrometeorological Institute.
So which countries are doing a better job than others in the EU and across Europe? Tomas, which weather services are sort of leading the pack?
Oof. Are you putting me in that?
Well, we hear from our Estonian correspondent Tarmo Tanaslu from time to time, and I see he, because it's like a fascinating patchwork, the map of Europe. These countries. You're right there in the middle in Czechia, between Poland and Germany. He's way up there in the north, not very far from Finland. But he gives us a report from time to time on their agency, and they seem to, back and forth. He's got good and bad comments about them. But are there any others that are just superior? I know when we were in Germany last year, we enjoyed the local weather service, app and their forecasts and seeing things like that, and it was nice to have. But we didn't get into any other countries while we were there. So comment on that as much as you can without getting in trouble, especially since probably some of those are your cooperating agencies.
Well, I have to say, in general, in the past 1 or 2 decades, many weather institutes have spent money, for example, to get forecaster trainings in terms of convective storm forecasting, which of course is very important as well. They have installed polarimetric radars, so there is also advancement in that field. They started using ensembles of high resolution convection allowing models. So there are numerous countries that started pursuing convective weather in a more concentrated way. I think that, of course, the bigger institutes, they have more staff to do more projects, and the smaller institutes and smaller countries can have smaller budgets for that. I would say that Switzerland, of course, you mentioned Germany, and I agree with Germany. Actually, with the German Weather Service, we have like the strongest cooperation for our test bed. So they really every year they give us some new products to test, whether it's some kind of a new setting of the model, or a completely new version of the high resolution convection allowing model, or some kind of a nowcasting radar based tool, or some kind of a mix of both. So we have very strong cooperation with them, and they really were very diligently also sending their forecasters to our test beds and courses. So we have very good cooperation with them. And they have done some major and very big advances in terms of how they approach convective storms and their warnings. I know that within the UK Met Office, I think that Met Office is also sending their forecasters and their products to the NSSL testbed. At least that's something that I have noticed. So they are also doing some more work there. France is also doing some developments. I mean, in 2000, and they have more motivation now than ever. I mean, in 2022, they had big hailstorms. They had a very long track tornado, one of the longest track tornadoes ever in Europe, and they also had they have an island in the Mediterranean. It's called Corsica, and that was very badly hit by a derecho with 62 meter per second wind gust, which is I think like 140 mile per hour. I hope I'm not mistaken.
That is a powerful derecho for sure.
Yes, that was a very, very powerful storm. So since 2022 and all the events, they have now a very strong incentive to pursue convective storm forecasting more.
Tomas, I recently joined the Royal Meteorological Society, and I've really enjoyed perusing a lot of the journals and past history, because I think, what has happened in Britain and the UK has been important to meteorology, just like Germany. Lots of research was conducted there. We're excited to talk about meteorologist Hans Ertl in a few weeks with Dr. Brooks, because he is the expert on those sort of things. But are there any other ways that folks in the States or in other places can get involved in European weather? Obviously, your organization, Toro, anything else you recommend that can make us feel more involved?
We are in frequent contact with the US researchers as well. We do have some collaborations, or we have developed some collaborations over the past years. I mean, in terms of the ESSL. So, for example, I guess you've had Chuck Doswell here from time to time, I guess, right? The legend. And actually, I inherited a course that he taught at the ESSL. So we invited him a number of times to come over to Europe and give a course on ingredients-based forecasting of convective storms. So at some point he was teaching the theoretical lectures, and I was doing like practical exercises for him, and that was really cool. Chuck has a very special way of teaching people. He can really make his point come across. So yeah, we cooperated with him, and we also invited a number of the professors from US on severe convective storms to deliver courses in our facility. So we've had Professor Markowski, Richardson, Professor Trett, Professor Parker. Yeah, so we are now actually, I can reveal this. we are planning a course with Professor Kamjan from Penn State on hailstorms. So we're trying to get the knowledge across the ocean to Europe. And for example, we've had a number of the SPC forecasters to come to our European testbed. So that was also quite an interesting experience. Some of them were unlucky though, because the severe weather was a dud, and so they didn't really get to experience something major. But well.
So I hope you guys haven't covered this. We have active weather here, so I'm multitasking. One of the things that we focus on here, it's FAR and POD, false alarm ratio and probability of detection.
Mm-hmm.
How are your numbers there?
Ooh, concerning the warnings.
First, let's start with false alarms. What's your false alarm ratio, or do you even calculate that?
Well, so that is very difficult for me to say, because these are statistics that national weather institutes will not share, or I'm not sure in what ways they are verifying their products. In a Czech Hydrometeorologic Institute, they have recently started verifying their warnings and making a public report. So this has been done in the last 2 years, and I don't know about the other institutes, so I cannot really make any comment there. But for example, majority of the institutes do not issue tornado warnings, so we cannot verify them. So actually, most of the institutes will not use the word tornado.
Wow.
They are because of the because tornadoes are pretty rare within some respective countries, and also because there is always an argument of, okay, the public will panic if they hear the word tornado in the warnings. It's very, very rare that you will actually see tornado in an official product of a European Weather Institute. Thunderstorm warnings, yes, but tornadoes, not so much.
So speaking of that, do you have folks on social media there that hype up things and create false forecasts to gain clicks and likes and shares and monetization on the major social platforms? It's a problem here. Is it a problem there?
Yeah, I guess it's a problem everywhere. You want to sell some headlines, so you need to hype it. Mina, I can tell you, in Europe there is an organization that tries to unify the warnings, at least on some level, across Europe. So there is like a traffic light kind of approach where you have green, like no warning, then you have yellow, orange, and red. So yellow is, so it's different in different countries. So sometimes in some countries the color only depends on the intensity of the phenomena. Somewhere it's both the intensity and the probability, or the likelihood combined. And there is sometimes a problem when they issue yellow warning, that in the media, the yellow and the red warnings are being hyped up in the same way. So just to generate the click. So then the public becomes, let's say, complacent, if that is the correct word, to when real big weather comes.
So one more question, and we do have to take a break in a second. Have you done television before? Television weather?
Yes.
Because for those that are listening and not watching, that's some real TV hair right there. I mean, that's some TV hair. If I had some hair like that, I would be a good-looking guy. Wow.
Thank you.
So and we got to take a break. So if anybody wants to get in touch with you, is there a website or a social media account you'd like to plug? This is your chance to plug away. So go.
So if you want to visit the website of our organization, it's www.essl.org. Or if you want to send me an email, if you have a question about European severe convective storms, or you would like to collaborate with us, you can email me at thomas.pucik@essl.org. So feel free to send me some email with questions.
Well, Thomas, we know it's the middle of the night, so thank you so much for giving us more than an hour. You're very kind, and it was a great guest. I've learned a lot by listening to this, so thanks for your work, and thanks for sharing your knowledge with us on the show this week. Thanks so much.
Thank you very much.
All right, and we're going to take a quick break, and we're going to come back with our email segment of the week. We're going to do email of the week with Jen, and we'll do picks of the week and more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
An interesting mission on an interesting rocket launched early Monday morning from Cape Canaveral. United Launch Alliance's CERT-1 mission lifted off successfully at 2:18 a.m. On board were 2 payloads. Peregrine, a lunar lander developed by Pittsburgh-based Astrobiotic, was put into a highly elliptical orbit, setting it up to land on the moon's Bay of Stickiness shortly after local sunrise on February 23rd. Peregrine's got a lot to live up to here. It's the first U.S. attempted landing on the moon since Apollo, and broadly speaking, lunar landers have less than a 50% success rate. The lander itself is about 8 feet high and 6 feet wide and has a payload capacity of 200 pounds. There are 20 experiments on board from the U.S., Germany, and Mexico. NASA payloads include a spectrometer to measure surface and subsurface water, CO2, and methane. Germany sent a radiation detector, similar to the one that orbited the moon during Artemis 1. Mexico sent 5 small autonomous robots, each about 4 inches wide. Dubbed Columna, Spanish for hive, they'll work together to study the moon's incredibly thin atmosphere. The second payload is from space memorial company Celestis, and it includes 62 capsules in a briefcase-sized container. Inside those capsules are DNA and partial cremated remains of people like Star Trek cast members Nichelle Nichols, who played Lieutenant Uhura, James Doohan, who played Scotty, and DeForest Kelley, who played Dr. McCoy, as well as show creator Gene Roddenberry and his wife Majel Barrett Roddenberry, who played Nurse Chapel. Also included in those capsules are some hair samples from Presidents Washington, Kennedy, and Eisenhower. Another, perhaps more significant first, is the launch vehicle itself. This was the inaugural flight of ULA's Vulcan rocket, which has been in development for a decade as a replacement for the Delta IV and Atlas V rocket families that have been popular with NASA, NOAA, and the US military for their ability to put payloads into very precise orbits. Just 17 Atlas V launches were made, and they're devoted to Boeing's Starliner crew vehicle to the ISS and putting Amazon's Kuiper broadband internet constellation into orbit. Elsewhere in the sky, this week is a good one to spot Mercury low in the pre-dawn sky. It's because it's at its greatest separation from the sun, making it easier to see. Look for a dim spot of light near the eastern horizon before dawn. On Sunday, look for Saturn near the crescent moon before dawn. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
This week in tornado history, an outbreak of 39 tornadoes occurred across parts of 9 states on January 10th, 1975. The strongest tornado of the day was given a rating of F4. It had a long track of over 56 miles through parts of Pike, Lincoln, Lawrence, and Simpson counties in Mississippi. Thomas Grzoulis in Significant Tornadoes notes that this may have been a family of tornadoes. The tornado developed near the dam at the lake at Percy Quinn State Park in Pike County. A marina and 7 other buildings were destroyed. The twister moved into the towns of Macomb and Summit, causing tremendous damage. There were 38 blocks in Macomb that had some degree of damage. 4 people were killed in Pike County. 1 was in an automobile and 3 others in an apartment complex. The tornado continued to track to the northeast into southeastern Lincoln County. 7 homes were destroyed and 8 had major damage. 5 mobile homes, 19 barns, and 17 other farm buildings, and also 1 camper was destroyed. 5 cars were demolished. 5 deaths occurred in Lincoln County. 1 was in a frame house, and 4 were in 3 of the 5 destroyed mobile homes. The tornado raced through northwestern Lawrence County, crossing mainly through forests and fields. In Simpson County, the tornado damaged a mobile home in the Bush community, and in the camper community, 2 homes were destroyed, and an anchored mobile home was torn apart and scattered across the road. Its frame was twisted around a utility pole.
On May 5th, 1975, Elvis Presley held a concert at the Mississippi Coliseum in Jackson, Mississippi. To help the victims of this tornado, he raised over $108,000. You can read more about this event and hundreds more at tornadotalk.com. Join the American Meteorological Society's Weather Band at amsweatherband.org to connect with weather enthusiasts all over the world, plus 10,000 plus members of the AMS. Swap stories and data, join photo contests and interactive webinars, or test your trivia knowledge. Full membership is just $12 per year. And don't forget to join WeatherBand February 29th and March the 1st from noon to 4 for the annual virtual Jamposium. As requested by WeatherBand members, the Jamposium will cover topics from climate change and severe weather to science communication, citizen science, and the April 2024 total solar eclipse. Go to amsweatherband.org to get started.
All right, let's dive into the email inbox and pick an email to read this week.
All right, our email of the week, it comes from our friend James Lewis. He had the one for Tomas, and he has one for James Spann. Actually, he has two. And this is about James's school visits. As technology has improved and more weather events have happened, how have your school presentations changed over time? And then the second question is, what sort of information or advice do you include now compared to 20 years ago?
Ooh, that's very good. You know, when I started doing school programs, this is embarrassing. This was 40 something years ago. I used to use a slide projector machine where you drop these physical slides in this carousel. Nobody remembers those things. But, you know, the nice thing about it now is that you can change things on the fly. I think the one thing that's changed is the fact that I have gone to counselors to get some advice on what kids need to see in first grade, second, third, fourth, when it comes to tornadoes. Some of the stuff is terrifying. Some of the damage is terrifying. And some of the younger kids, the kindergarten kids, first graders, don't need to see all of that. They do need information and they do need to see some stuff. But I think that's the best part of what I've done is integrate the information from counselors into what I do so I can appropriately give the kids information they need about staying safe during severe weather. And the other thing that's changed is the glut of things I have to show them. Goodness gracious, with the content I get from the followers now on social media, it's a smorgasbord, and you can change it. And I've probably got 10, 12, 11, files loaded with different content. So it's much better than it used to be, and it's just going to keep on getting better.
Awesome. Thanks, James Spann, and thank you,
Oh.
James Lewis, for your email. Email at weatherbrains.com for more emails that we will get to you each and every week.
Well, let's do picks of the week here. And by the way, let me just say, we're going to try and make our show a little shorter going forward. You know, there's a glut of media. I mean, everybody's got a podcast. You know, the guy down here at the Arby's, he has a podcast, and there's so much content, and people can only consume so much in one day, in 24 hours. And we think it would probably be best if we shortened up the show a little bit from 2 hours to maybe closer than an hour 15 or an hour 30. So we're gonna work on that because again, it's just hard. I listen to a show that's 3 hours and they do it twice a week. I never make it through either show during the week. So we're gonna work on that. So let's do picks of the week. This will be something weather related that is cool for the masses. And let's begin with Rick Smith, who always has a good pick. Rick?
I think I may have addressed this in a recent newsletter article, but the Weather Prediction Center has the Winter Storm Severity Index that they've been experimenting with. They also they now have a probabilistic version of that. And given the weather that's going on tonight and that will be going on through the next weeks, months, however long winter is going to be here now that it's arrived. I think it's an interesting product to take a look at to kind of give you a different take on winter weather hazards, whether it's snow, ice, whatever. So Winter Storm Severity Index, the probabilistic version is my pick.
Excellent. And again, all the links will be up on the website, weatherbrains.com. James A., give us a good pick.
Yes, sir. Mine is from Ryan Hollister, who is a geosciences instructor in California's Central Valley. He lives in Turlock, and occasionally they get some Arctic air in the Central Valley of California. And when that happens, The visibility is spectacular, and he took a picture at the end of his street, and you can see Half Dome in Yosemite National Park from his street in Turlock, which is 72 miles away. And it's just a spectacular picture. And Half Dome was not visible from 72 miles away when we were there this summer, but it's still worth a visit if you can ever get out to Yosemite.
Excellent. Are you growing some facial hair, or is that just my screen here?
It could be both. Yeah, since I haven't had to shave, I have not shaved.
You know, the only hair I can grow comes out of my ears or my nose, and so it's just not working for me.
You can braid it; it might look nice.
Well, that's true. You never know. All right, Jen, give us a good pick of the week.
Oh boy, mine is from the Weather Prediction Center. It's the short range public discussion. When you are covering as much as I am from coast to coast, I just cannot look at every single forecast and all the nuances. I just don't have time. So this gives you just such an awesome review of what's happening across the country. They issue this twice a day, and just give you the trends of, here where the storms are, here's where, stuff is happening. And it's just a great overview. If you're a weather geek like we are, you just want to kind of know what's happening, where all the storms located. It's a great resource for you.
Excellent. All right. And again, the links will be up on weatherbrains.com. So my pick, by the way, it's obviously, and I guess it's because I'm dealing with it now, but it's a website that really does a pretty good job of depicting power outages across the United States, poweroutage.us. And it takes into account basically all of the utilities, and you can get down to the state or the county level and get a real-time look at how many power outages are there. And it's very helpful, obviously, on a night like tonight where I am. All right, Bill Murray, go. What you got for us?
Yeah, James, I'm going to talk about next week's guest. Randy Cerveny going to join us, and he's got a new book out. So I'm excited about that, and a bunch of other great guests coming up. It was nice to have Tomas on the show tonight, but I'll take the Foghorn for my official pick.
Ooh. Ooh, I just like the sound of that thing.
I do too.
All right. So if you are new here, we're typically on the air every Monday night at 8 o'clock Eastern, 7 o'clock Central. And you can watch this live or later on our YouTube channel, youtube.com/weatherbrains. But we fully understand that most of you listen to the audio podcast. However you consume this, we thank you as we approach our 18th anniversary. If you'd like to get in touch with us, again, the email address, it is email@weatherbrains.com. On behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week, and God bless.
We just gusted to 49 miles an hour at BHM.
Woo. Yes, getting a little, the power outages are really ramping up here. I don't know if we're on generator here or not, but typically our generator, it kicks in just like that. So, all right, well, we're going to get to it here. So thanks, everybody. We'll see you all next Monday night.